Hello. Um, I am presenting the presenter Jorge Alarcon. He is the Global Technical Manager OCM of Bureau Veritas, and he will be discussing predictive maintenance technologies integration for monitoring and prediction of condition patterns. You can find more about him and connect in the speaker profiles.
Hello, and welcome to this session about predictive maintenance technologies integration for monitoring and prediction. My name is Jorge Alarcon. I work at Bureau Veritas Oil Condition Monitoring. We operate 16 labs around the world. We analyze not only lubricants, but also coolants, diesel, grease, and some other industrial fluids. I'm the global technical manager for the company, and I'm a reliability engineer, and I've been in the field for around 18 years, working with many different sectors of the industry. So if we start analyzing the data that we had a couple of years ago in 2018, depending on the source, we can identify that around 1 to 3 billion of industrial machines were connected. We mean connected to the internet. To some kind of platform that allow the end user to see the real data, the actual data that the equipment is having during the operation. So what happened a couple of years after, between 2019 and 2020, depending on which part of the world you are, we have been hearing that 5G technology is available. So 5G will change dramatically how the things, not only in the industry level, are doing. It will change a lot about the way that we as a human work during the day. So, for example, with 5G technology, we will be able, or the machines will be able not only to transmit information and data as numbers, but also videos and sounds, and so that will create a whole new world for. Not only the way that we will receive information, but also and how are we going to create, what are we going to do with that information. So we expected around between 2023 to 25, depending on the source, around 46 billion of industrial equipment will be connected to the internet. So that will create a different type of market with new business models. The integration of machines will create a new industrial world. So just in a couple of years, less than five, around 5, depending on the source, we'll be living in a completely different world because of the availability of the information that we'll have in our hands. So some years ago in 2014, I asked a group of clients if their site were pursuing a real-time oil condition monitoring. And at that time, the answer was what we have here. So around only 1% will have at that time full digitalization on critical machines. Of course, we are talking about here large turbines and compressors and stuff like that. Around 8% will start a pilot project at that time. And around 14%, they have some people of their company trying to understand and looking for the pros and cons about the oil condition, the real-time condition monitoring. And around 77 of those industries that I talked at that time, they were doing nothing related with real-time condition monitoring. So I asked the same question every year after 2014. So let's take a look at the answers that I found in 2021. At the beginning of this year, I asked the same questions to pretty much the same group of clients or end users that I asked the question in 2014, and the results are completely different. So full digitalization, it's 2 times what I asked in 2014. The number of projects that were increased by 3. We're talking about just 7 years. Learning about the benefits and pros and cons will jump from 14 to 46. And the industries that were not doing and they are not doing nothing, it's around just half of what they were doing in 2014. So this means that a lot of people is moving towards real time, and in this case, oil condition monitoring, right? But a lot of people are having projects on real time condition monitoring, not only for oil, but for any other predictive maintenance technology. So we can see here how the market is going towards, at least is looking for something that is integrated in real time with platforms. So if that is the case, what does it take to see the impact of sensors in the market? Because we're talking about a lot of people putting projects, pilot projects, a lot of people installing sensors. So a lot is happening, but we are not seeing that impact yet. So I developed a study back in last year, and I was analyzing the impact on reliability and the maintenance benefits that we will have from the sensors. But what is happening? Why we are not facing that stage yet? And the reason is very simple, right? So for a sensor to be in the market, we are talking about that the company has invested a lot in research and development. And at the same time, the component, the size and the price of that component, that sensor was really high that it cannot get into the market until it fell into the market with a reasonable price. And at the same time, the research and development technology would allow to put that device into equipment, for example. So we're talking about, in this case, about the market penetration. So we are in this stage here with the market penetration start. We had components that are a size of a pen, and they are pretty much under $1,000, $2,000. So they're accessible for any type of industry. If we go back a couple of, let's say 10 years ago, I was working on a project where the size of the component was not accessible to install in a gearbox, for example, because it was probably twice of the size of the gearbox, and the price was extremely high, right? So we are in this phase right now when the market penetration has broken, a lot of new devices, new technologies in the market, but we are not facing the impact as the way that we would like yet. The main reason for that is still price. We're talking about sensors that are still out of the range of many companies, but the most important thing is that the applied knowledge from that sensor is not what we would like to have yet. We are not in the phase of understand 100% what the sensor is telling us. And that is the problem right now. For some companies, price could be a problem, but for some others, understanding what's really what is the value of having that sensor installed in the unit is the main issue. So we will get to a point where the sensors will impact on reliability and maintenance and cost benefits when these two things here get down, and we will understand basically what the sensor is telling us. So for example, in this case, this is a particle count sensor in a gas turbine that was installed in 2014. For the first 2 years, the end user was not able to understand why the particles were increasing in some period of time. After the integration of the sensor technology results with the operational results, we were able to understand that a low temperature will increase the particles in the system, which is something very basic from the oil analysis perspective, but not for the sensor. So we need to feed this sensor with this knowledge before trying to get what the sensor is telling us. Another good example is the metallic wear debris sensor in a gearbox. For example, working a project where this gearbox had installed a metallic wear debris sensor, but it was really close to the functional failure of a component, right? So the integration of these two technologies, the oil analysis lab and the sensor, will increase the range of detection of the problem that the gearbox is having. I'm not saying that this one is better than the other, but these are complementary technologies. And we are moving towards the integration in some fields, not only between different technologies, like in this case, but also integration with operational data, like in the previous case. So we are starting to see this integration or more often in different fields. So what is this integration for? We are talking about probably a sensor for oil analysis sensor. We're talking about operational data. It could be temperature, depending on the component that we're talking about, pressure. It can be generation of energy, and the predictive maintenance technology that was previously installed or it was previously working in this component. From our perspective, this is the oil analysis lab that will feed the information on the chemical changes and the contamination and some other variables that we have from the oil analysis lab. So what is the boost? What is boosting these three things, and what is when are we going to see a change, a real change in this scenario, and why? It's because artificial intelligence, right? So artificial intelligence is the enabler that will allow us to put at least these three things together. Probably a couple of more, depending on the type of industry or the type of component. But artificial intelligence will allow us to put at least these three things put together. So the reason why artificial intelligence is going to do that is because the amount of data that we have accumulated, or a sensor plus operational data plus the oil analysis can have, can only be analyzed by a different approach than the ones that we are having right now, and that is artificial intelligence. So it's probably a key component on this entire new scenario that we are getting into. So a couple of some months ago, I was invited to analyze an artificial intelligence, I'll say, software for oil condition monitoring. So in a base of 250,000 results that I was able to evaluate, I found that there was a problem. Around 68,000 of those results were incorrect results. And the reason was very simple. The main variable, the one that has more weight in the algorithm, had a lack of a specific knowledge. We're talking about knowledge from the oil condition monitoring perspective or lubrication perspective. So because of the weight of this variable, around 60,000 results were incorrect. So to do an analogy of these artificial intelligence algorithm in this case, it's like the people from Deep Blue. At that time, when he played with the computer played against Kasparov, will tell the queen, will tell the software that the queen can do the same moves at the night, right? So if that will happen, so the queen will start doing some unusual movements, illegal movements, and the game will be over. So exactly the same situation. We're getting into a more and more artificial intelligence field. A lot of people is talking about artificial intelligence, but we cannot forget that the base of all this is the knowledge coming from, in this case, an oil analysis lab, the operational data, and of course the sensor. So it's very important. Artificial intelligence will change dramatically the scenario for in this case for oil analysis. But we have to be aware that the base knowledge, the fundamentals of oil analysis are absolutely important in this case. So I'm going to show you a couple of examples that I've been working through the years. The first one is grease analysis. Integrated with two different sensors. In this case, we have a bearing temperature sensor and the nozzle temperature sensor. We are talking about, of course, in the wind industry in this case. So first of all, we had a lot of information on grease analysis and bearings, right? So I'm talking about more than 1 million of analysis in a database. So we know what is wrong. We know the failure modes of the grease, not only the failure modes of the component, the bearing, but the failure modes of the grease. So we can understand at some point when we have a result, where that result may go. Right, so we put this this information together with the bearing temperature sensor, the inner sensor, and the nozzle, because the temperature, we found that the nozzle temperature also has an effect on the grease. So what we found, for example, is that the temperatures, of course, we know that the temperature will increase if there's a lack of grease. If we have no grease, to run the lubrication in a bearing, of course, we will have friction, metal-to-metal friction, and that will increase the temperature of the bearing. If that temperature is increased, we know that we will have a presence, an increasing on iron elements or ferromagnetic elements, right? So if we filter those units that had an increasing on temperature, we will easily know which one will need more attention. But these are just two temperature sensors, and we need to add what is the grease analysis in this case. So we are talking about probably that a site may have around 100, 200 to 300 turbines. So it means that they can have 300 main bearings. So which one is the one that we need to pay attention? So based on the algorithm provided by the temperature of the nozzle and the temperature of the inner bearing and the grease analysis, we found that only these units may need attention in the next 3 months. So we can forget about the rest 295 units and focus just only on this 5 units that are really suffering from wear due to many different reasons. So basically what we are doing is isolating those that need attention. So this is just an example of how the integration of different technologies like grease analysis in this case and the operational data like the temperature can get a benefit for the end user. Those are the units that need more attention. So what is the path for to have an artificial intelligence combined with an OCM, with the oil condition monitoring? So the first thing is data collection from many different PDM tools, not only the lab, but the sensors and operational data. The second step is to run a data analytic. platform, right? So starting with a statistical analysis, clustering, segmentation, and of course, and this is the most important part for me, oil condition monitoring, specific knowledge and expertise. A lot of companies that are putting a sensor into the equipment, they forget that they need to have that specific knowledge. What does it mean? What the sensor what is the information provided at the sensor? What is a specific meaning of that of that information? And based on that, we the next step is to create a prediction model. So a prediction model is basically what's going to happen if, right? So in the simple example that I showed you before, what happened if the temperature will increase in a couple of degrees? We will have an increasing on a potential increasing on the wear debris because of friction of metal to metal in the components, right? So prediction models are the third step, and the last step is to apply that the information that we have from the prediction models to the real data that we're having at that specific point in time. So just to conclude, at some point in their life, predictive maintenance solution providers have the opportunity to combine years of data with applied knowledge. Therefore, they can go from being a service provided to a value-added data analytics company. So it means that in the next couple of years, in the next 5-10 years, we will see a lot of new companies playing in the market, because the knowledge that is in the data information that these companies have can create a new type of business. So the line that separates this type of company from this predecessor is very thin, but it requires immense effort. It will take some time to get all the parts in place. So artificial intelligence, oil condition monitoring, operational data, and some other sources will be together and mixed and provide just one unique solution. But I think in some areas of the industry, we're moving to these new type of business, where we are having information from many different actors, like sensors, the lab. I saw I was in a vibration project that includes also oil analysis and operational temperature, for example. So we're moving towards this new scenario. So what is your company going to do? Are you getting more information on the fundamentals of the oil analysis? Are you planning to integrate a sensor on your critical components? Let me know, and I would like to hear from you about this new scenario that we are getting into. Thank you for your time.
Hello. Jorge is unfortunately not available for the question and answer segment, but you can reach him and his speaker profile, and he will get back to you. And thank you. I hope you enjoyed it. Oh, wait. Jorge, are you available for the Q&A? I'm not sure. Okay, there we go. Hello. Hello. Can you hear me?
I can hear you. Can you?
Yes. Okay. How's your internet doing?
It's wobbling due to the storm. Yeah, I'm really sorry about that.
It's not a problem. We have about 6 minutes of questions. We have some comments here. The number of internet connected sensors show the inevitable impact of IoT sensors Sending IoT sensor data for external analysis is an interesting way to tap into this community. So that's a comment we've got.
Yeah, we have seen a lot of new companies, new sensors, new technologies, new developments, and new pilot projects. So that explosion is creating a new type of individuals that are getting more knowledge. So at this point, we are in the phase of acquiring knowledge. We are not reached the level that the sensor will tell us what to do, when to do exactly yet. But we are getting towards that situation. I don't know, a couple of years, maybe, depending on the type of equipment. Of course, some others are really ahead of some type of industries. For example, turbine, due to the cost of a unit, those will lead in the path here, for example.
Awesome. The next is, this is the future, and it's not surprising for those of us who have been in the field. I think we need to increase conversations with major decision makers in our respective companies to ensure we have the buy-in when the time comes for integration.
Yeah, so I think the people in the sensor sector, they already know that they have been knocking a lot of doors, OEM doors, and a lot of the people that design the equipment. Some of them are opening the doors to these new technologies. Some other, they just don't want it. They want to have this sensor for later, so the end user can add that as an add-on. But yeah, I think the OEMs are already aware of this situation. Like in the aviation industry, right? A lot of sensors. We are start seeing the same exactly situation at the floor level here in the industry.
Someone said, Ravi said, I am currently working on a project to monitor vibration analysis halfway across Canada. From your presentation, I feel compelled to include oil analysis for the larger gearboxes.
Yes, it's a must. It's a must. I'm not saying that I'll never going to say that one is better than another, but those are complementary technologies. I've been in many different projects where we put the vibration and the oil analysis technologies together. And we were able to identify different type of failure modes, the ones that the vibration can do, and the other ones the oil analysis can identify. So these two technologies are extremely important, and they work together. They can really work together and have really good results.
We have a comment from Guillermo, which is a sector that has experienced the major change in the sensor adoption evolution you showed before?
So based on the studies that I have been doing through the years, of course, power generation is the sector that is leading this change, mainly because the cost of a turbine, of a compressor, but is not the only one. I think behind that we have the wind sector, that it's trying to get more knowledge about sensors and these new technologies.
From Syed, any comment regarding cybersecurity if data are exposed in an internet environment?
Yeah, so this is the question, right? The end user don't want to use the platform of the technology manufacturer sensor because of these reasons, right? Cybersecurity. So I think the ones that are getting into this part are the lawyers, or those that are going to say what is your part of this knowledge, and who should take credit for what you're learning or what the sensor is telling us. So that's a very extremely difficult field right now, and I don't feel no one has a good answer right now for this point.
Christopher said, predictive models for oil temperature, particle sensors, accelerometers, and such needs to know in what context the equipment is used. How do you gather customer data about how the equipment is used for use in predictive models?
So this is a part of the phase one when we develop a couple of algorithms. What the first thing that we did is telling the algorithm or feeding the algorithm with the basic information, right? So, for example, a marine engine is a completely different than a gas engine that it's on land. So this is the basic part of feeding the algorithm and saying to the algorithm, this is right and this is wrong. Now you have to make the decision. So this is in the part that this is right. So creating that base for the algorithm to start taking the decision.
All right, that is all the time for questions we have. Thank you. You did a wonderful job. And thank you for everyone for participating in the question and answer. Bye.
Thank you. Bye.
Thank you.